Hello, my name is Trevor, and today I'll be demoing Flux. Now, Flux is a very basic, and I mean, it's literally just arithmetic, but it's a very basic CLI application that I use for music. Now, music is a big part of my life. In my free time, I'm always producing, recording my friends, and doing a lot of sound engineering and sound design. Now, a big part of that hobby is working with time-based effects. So, for some domain knowledge for you guys, I'm going to play a demo of this song I'm working on, and I'll give you an idea of what this time-based sound effect is. So, FL Studio right here, just going to play this segment of the song, and yeah. So, you'll hear some raw vocals. Focus on these. So, focus on how, I guess, dry sounding the vocal sound. Those are pretty good vocals, good singer, nothing's wrong with them. However, if we just added some reverb to the vocals, then they would just be a lot more atmospheric, a lot more just airy, I guess, is a good word to use for those. But I just toggled the reverb back on, and so now you should notice a pretty big difference in the vocals dimension, if you will. Without it, with it on. So you see how it just adds that dimension to the vocal, right? Pretty cool. Very popular effect in a lot of pop songs. And so this is what the actual plugin looks like. And we're focusing on these time parameters right here, the decay and the pre-delay. So as a sound engineer, it's my job to make sure that these two parameters are dialed in, right? And so the most common practice is to just get a calculator out, right? And you see this right here, this 117, that's our beats per minute on this particular song, right? And so just some math basically just converts the beats per minute into, it just factors it into seconds or milliseconds, right? So a basic formula is like 60,000, which is, I couldn't tell you what that actually means, but it's something useful. It's like seconds, it's like some kind of second factor. And so then we divide it by our BPM, by 117, and then we get some number, and then divide it by 16, cool, 32. So this is the baseline for our pre-delay, right? This means that whenever the vocal is sung, it'll wait 32 milliseconds and then it will activate the reverb. So for our delay, or sorry, our decay, we will just multiply this by maybe 32. Cool. We have 1 second multiplied by 2 for 2 seconds. Cool. So 2.05 seconds, right? So we're kind of close already, we kind of ballparked it, but this would be how you get your baseline reverb, right? This means that the reverb effect that you heard, that kind of airy, that nice effect, it's going to be on time with the beat. So whenever your reverb kind of falls off when it decays, then the beat will hit, right? So it's pretty hard. You can't really notice it, but there is a sonic difference, and it's a good way to just give you a baseline for how your timings for your effects should be, because then you can, adjust it to your taste. However, you saw it's kind of tedious, right? To just get those values, to get the 2051, and then when you're making an actual song, there's so many instances of reverb, right? Using reverbs, even other effects like compressors, right? There's so many times you would use them. And so you're going to have to constantly be referring back to this calculator. Maybe you exit out of it and then you just can't, you have to do the entire thing over again. And I just found myself getting really annoyed by this process because it's really useful. Like, getting these effects down is a game changer. And so I was like, well, this is a pretty, repetitive task, so let me just make a Golang application for this. And that's where Flux comes in. So Flux, you can download it on the GitHub. It supports Mac, Windows, Linux, and it's very simple. Just go T, boom, enter the BPM of the song. So we saw here it's 117, so we'll enter that, 117, awesome. And then look at that, it just magically, it's basic arithmetic. It just feeds us these ideal baseline timings for reverb and compressor. As you saw, it's pretty close to what we calculated earlier on the calculator, but this is just a really useful way. And also, I think there's a shorthand as well to just do the BPM like this. Yes, same thing. So one less step, just go T and then the BPM, and boom, you have your baseline, right? So very useful, very simple. It's just math. It's just dividing it, doing the process that I showed you guys, manually. It's just doing that, but it's very simple. And I'm constantly using this tool to get my timings right and just get those reverbs, those compressors sounding perfect. So yeah, that is Flux in its totality, right? Pretty basic. Now, as far as what I've learned from this project, well, firstly, I've learned how to make a Golang command line application, which is super cool. I used only the standard library, which was honestly super fun and intuitive. Go's documentation is very rich and easy to read, so honestly, seamless experience. Secondly, what I learned was how to upload a command line platform independent application to GitHub releases. So previously, my apps have been deployed to Railway or Vercel or on AWS Amplify. And so it was new to me to actually make a application that people could download the binary to their computer and then just use it on their desktop, which is a lot more easier for my non-technical friends that don't really know, how to connect to a REST API, so that was really cool as well. Thirdly, what I learned was a little more conceptual, I guess. This project just changed how I viewed computer tasks and how I viewed my workflows with things such as music or maybe with 3D modeling. It's a can of worms. Like, it kind of taught me that all of these redundant or repetitive tasks that you feel like can be cut out or optimized, I can do that, right? Like, this project has proved to myself that I can actually make these cool little programs and even give it to other people that can optimize these workflows I have. So that was super cool as well. It was like it's like I have a new superpower, right? So as far as what features you can expect to be added to Flux, I have two ideas. So the first one will be another parameter on the application, which will be the vibe you want with your time-based effects. If you want a more atmospheric vibe, more poppy vibe, then it'll use a formula that gives you longer delay times, gives you longer compressor release times, because those are the kind of parameters that are in those genres. Like, when you do this for a long time, you kind of realize what genres have what different flavors of compression and reverb. So, I think I could translate that knowledge into the application to make it easier for users to get the parameters they're looking for, or the output they're looking for. The second thing I want to add is, I guess, more operating system side. I want this command line application to actually be able to scan your processes and attach to any digital audio workstation processes and then grab data from that process. So, for instance, DAW, what I just mentioned, is like FL Studio in the background. So it would be able to read the BPM just without user typing it in. I think that'd be pretty cool. And then I can also extend the application, infinitely if I could get that information. But that'd be cool. That's far shot down the, to-do list, because I have a lot of other projects I'm working on. But I think that would be a really cool addition to the project. Now, that being said, that is my demonstration, what I've learned, and expected features of Flux. Once again, my name is Trevor, and I'm so glad that you watched this video and saw this demo. And yeah, have a great day.